Alright, welcome everybody. Today we're going to talk about mass spectrometry with molecules. Now we've done this with atoms. We've talked about how you can do this for isotopes, but now today we're going to actually talk about how to do this for different molecules. And so when we do this, we're going to look at the masses. And just like we were able to deflect the different masses of particles when we used it with isotopes, we're going to be able to do the same thing with molecules. So, here is our mass spectrometer again, and so we have the steps where you have the sample that enters, it gets vaporized if necessary over here, then it will be ionized, then it will be passed through a magnet where you have the deflection, and then we have the detection. So we're going to see the same thing here, but now we're going to be dealing with full molecules. So, how do we go about doing this? Well, we look at fragmentation patterns. And so the idea is that we're actually going to remove an electron from an atom, and when we do that, we are going to have a charged particle. And this is what allows the particle to be detected. Now also, you can have these, collisions taking place where with the ionization process you have the molecules breaking up into different fragments as well. And so you're going to see a fragmentation pattern forming. So what we're going to look at in a fragmentation pattern is we're going to look for peaks. The largest peak will always correspond to that big parent ion, the one that just has one electron knocked off of it and has the rest of the complete molecule intact. Other ions that you're going to see, they're going to be smaller. They're going to be the fragments that broke up from the larger parent ion. Now what we're going to hope to do is piece together the fragments in order to figure out what the molecule actually is. This is some awesome scientists collecting data. And here's an example for you. So this is ethanol. And so if we were to add up ethanol's total mass, we would get a total mass of 46 grams per mole. And what you're going to see is that there is a peak at 46 grams per mole. Now we also have a peak where we've lost a hydrogen. And so that would be our 45. Now we're going to also have a peak where we lost other particles as well, like for example, the methyl group. So this 31 right here is equal to 46 minus 15. That gives us 31. Well, where could 15 come from? It would be if we lost this methyl group. This fragment would correspond to CH2OH+. Notice I put in the ion charge there to show that it's a charged particle. This part here would be CH2, CH2OH+, or perhaps we lost the H on the end. Now notice this 15 over here, it comes out on this end right there. And so on this over here we have our CH3+ that came out. Now what could the 29 be? Well, the 29 could be 17 minus the 46. So if we do 46 minus 17, we'll get that 29. Now what could weigh 17 that could come off? Well, the OH. And so this fragment right here could be the CH3, CH2 positive. It lost the OH. Now notice we don't see the OH fragment here, but this example is showing you ethanol. And so we can go back and fill this in again, but showing you here, I don't know why I have it 4 times, showing you it here, here's showing you the different fragments. And so you can see, like we lost the CH3 group here, we lost the H, they took it off of the oxygen, this is the parent ion here, here's the C2H5+, so that lost the OH, and here's the CH3 that's coming off on the end. So overall, what we have is these fragments that can add up to the total. Now remember what I said last time, that you have IR spectroscopy. And IR spectroscopy, that's great. That's for looking at different types of bonds and functional groups. Here we have a different technique, mass spectroscopy, and in this case, when we have this technique, we actually are able to get fragments with different sizes. Put together, those two techniques could tell you a lot about the atom. But there's still a piece missing, and that piece missing happens to be the NMR data. So just to recap here, the highest fragment, that's going to be the total mass of the compound, the parent ion. These fragments, they provide clues about what the structure of the atom is. If you want to know what fragments you're supposed to be able to recognize but not memorize, here they are in the table that's from your data table. We have the 15 grams per mole is a methyl group, 17 was the OH. We have other groups that they list here. Ones we saw in ethanol was the 31 group. So we saw a bunch of different ones here. Okay, the next thing that we'll do is NMR. And with NMR, it tells you the location of hydrogens. There are different types of NMR, like there's carbon 12, carbon 13 NMR, but we're going to focus only on hydrogen NMR. And we'll do this next time. So that's it for this particular video. We need to really practice, and these videos are kind of short because they're just here to give you some practice about what it is that you need to know. Alright, so we'll do that and we'll practice some of the problems in class, and hopefully that will give you a good idea of mass spectrometry. Alright, thanks for watching.